This is a fun question. It asks us to determine the concentration of sodium chloride in a solution that's 2.23 molar. That means it's got 2.23 moles of sodium chloride in 1 liter of water, and I have to determine what the percent concentration of sodium chloride is by mass. Well, you should remember that determining a percent concentration by mass of any solution is that whatever the component is in that solution that I'm trying to do it for, I take its mass and divide it by the total mass of everything in the solution times by 100. Let's reason through this. If, for example, I got a bucket of water with sodium chloride dissolved in it, and I want to figure out what is the percent mass of the sodium chloride in there. All I do is determine what the mass of the sodium chloride is, what the mass of the water is. I take the mass of the sodium chloride, put it on top of this fraction, and then divide it by the total mass of the sodium chloride plus the water together, times it by 100. Does that make sense? I could do the same thing for the water as well if I wanted to determine what the percent mass of the water is by concentration. To do that, I would take the mass of the water and divide it by the combined masses of the water and the sodium chloride together in the solution, times by 100. So in this question, it asks us to determine the percent composition by mass of sodium chloride. So that's the component particular that I'm looking at. And it gives me the density of this particular solution as being 1.01 grams per milliliter, just so you know. So the real trick then is I have to do some kind of mathematical finagling in order to figure out what the mass of the sodium chloride is in the solution and what the total mass of that solution would be. So how in the world do I do that? Well, let's begin by taking a very simple, easy to calculate amount. I'm going to imagine if I had 1 liter of this particular solution. It tells me that the molarity of this solution is 2.23 moles of sodium chloride in 1 liter. So if I had 1 liter of this solution, I would have 2.23 moles of sodium chloride. Can I determine what the mass of sodium chloride would be in that 1 liter of solution? Absolutely I can. 1 mole of sodium chloride happens to weigh, I think, 58.5 grams. And you can calculate that from the periodic table. Moles cancel each other out. I multiply those guys through. And that gives me 130.5 grams. So if I had 1 liter of this particular solution, it would weigh, or it would contain 130.5 grams of sodium chloride. I'll write that kind of crappily off there to the side. That begs the question, though, what would the total mass of that 1 liter of solution be? Well, it gives me the density. And remember, density is the intermediary between volumes, such as milliliters or liters, and masses, such as grams or kilograms. So that's kind of the key here. If I had 1 liter of solution, what in the world would that weigh? The problem is that 1 liter doesn't match up unit-wise with this that has milliliters. So I'm going to go ahead and throw down a liter in the denominator, remembering that 1 liter is equal to 1,000 milliliters. I'll throw milliliters in this denominator by grams. 1 milliliter of this specific solution weighs 1.01 grams. You'll notice the mills cancel each other, liters cancel each other. I'm left with a number of grams of this solution, which comes out to be 1,010 grams. So 1 liter of this solution that has this density would weigh 1,010 grams. And it would contain 130.5 grams of sodium chloride. So what is the percent mass of sodium chloride in that solution? Well, all I do is take 130.5, divide it by 1,010, and I times that by 100. I get the answer to that. That is the percent mass composition of sodium chloride in this solution.